Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Satellite Communication, and today's lecture topic is Analog Digital Transmission System from Satellite Access. On completion, the students will be able to understand the difference between analog and digital transmission and also describe the techniques used to send digital data using analog technology. Analog transmission. An analog waveform is characterized by being continuously variable along amplitude and frequency. Analog facilities have limited bandwidth, which means that they cannot support high speed data. Another drawback of analog transmission is that noise is accumulated as the signal is traversing through the network. As the signal moves across a longer distance, it loses power and becomes impaired by factors such as moisture. By the time the signal is reaching the amplifier, it is not only attenuated but it is also impaired and noisy, ending up with higher error rates. Digital transmission. Digital transmission is quite different from analog transmission, and here the signal is much simpler. Rather than being a continuously variable waveform, it can be expressed as a series of discrete pulses representing in zeros and ones. Digital networks use a regenerative repeater. This regenerative repeater regenerates the weak and impaired signal to pass on to the next block in the network, in the essence of eliminating noise and thereby vastly improving the error rate. Comparing analog and digital transmission, the data is continuous in analog signal transmission as well as it is discrete in digital transmission, and the signaling is a continuously varying electromagnetic wave in the analog case and is a sequence of voltage pulses in the digital case. The digital technology has an advantage of data integrity, which refers to higher accuracy and consistency of the data that is being transmitted, and the repeaters enable longer distance transmission in such a way that data is transmitted with less error. Easier to multiplex larger channel capacities with digital transmission, and also high encryption methodologies can be employed to digital transmission to improve its security, and better integration is present if all the signals are in one form. That is, it is normally difficult to integrate voice video in analog form along with digital data, whereas if the signals are in the same form, then it is better to integrate. So this diagram shows the representation of a basic communication systems with a source and receiver along with a channel, where the source includes the encoder as well as modulator, and demodulator and decoder are present at the destination site. Digital transmission of analog signals. To transmit analog message signals such as voice and video signals by digital means, the signal has to be converted to a digital form. This process is termed as analog to digital conversion, and also sometimes referred to as digital pulse modulation. Two important techniques of analog to digital conversion are pulse code modulation and delta modulation. Digital data analog signals, that is representing digital data using analog technology. The sender here generates a carrier signal at some continuous tone that looks like a sine waveform, and the resulting bandwidth is centered on the carrier frequency. Some methodologies involving this transmission includes amplitude shift keying, frequency shift modulation keying, phase shift keying, as well as frequency division multiplexing, time division multiplexing, statistical multiplexing. In amplitude shift keying, here the signal vary in such a way that it is able to transmit the digital data over an optical fiber. So the amplitude, that is the voltage of the signal, is varied here. In frequency shift keying, two or more tones are being employed, and the nearer signal to the carrier frequency is being assigned. Here this is employed in the case of a full duplex modem, where signal transmission is supported simultaneously at both directions. In phase shift keying modulation, Here it employs systematically shifting the carrier wave at uniformly spaced intervals, and the wave shifting is such a way that it could be shifted by 45, 135, 225, 315 degrees at each timing, and the shifting carries 2 bits of information. Here shifting is not performed as 0, 90, 180 or 270 degrees. This means 0 degree shift means there is no shift, and an extended shift of no shift leads to clock synchronization issues. In frequency division multiplexing, the frequency spectrum is divided into smaller subchannels, giving each user exclusive use of a subchannel. One problem with FDM is that a user is given all the frequency to use, and if the user has no data to transmit, then the bandwidth allotted is being wasted, which cannot be used by another user. Time division multiplexing. Here a time slicing is given to each user for the entire bandwidth, but this time slicing is for a limited fraction of second, and again here if the user is not having data to be transmitted, then the bandwidth is being wasted. Statistical multiplexing. This allocate bandwidth to arriving packets on demand. It leads to the most efficient use of channel bandwidth because it carries useful data transmission for an allotted time period, and here the channel bandwidth is allotted to packets that are waiting for transmission, and a user generating no packets will not be provided with resources. Therefore, bandwidth wastage is avoided. Quiz questions on analog digital transmission system. Differentiate between analog and digital transmission. Describe the techniques used to send digital data using analog technology. Thank you.